Now it's your turn to apply some of the concepts that we just learned, but in a new situation. Suppose that David Craig is now unhappy with the waiting times of customers under either arrangement of lines, either having a line in front of each cashier or a single line in front of a group of cashiers. David Craig's goal now is to ensure that average customer waiting times are 1 minute or less. The question we'd like to answer now is how many cashiers must David Craig hire in order to achieve this objective? Clearly, the answer will be different depending upon whether David Craig has separate lines in front of each cashier or one long line in front of a pool of cashiers. In order to begin to answer the question, let's first remember some basic data from the case. First, the arrival rate of customers to the supermarket is 80 customers per hour. Second, the average amount of time it takes a cashier to serve a customer is 3 minutes, which corresponds to, on average, each cashier being able to serve 20 customers in an hour. Using the formulas for the MM1Q, we can back calculate to figure out the minimum number of cashiers required in order to ensure that customer waiting times are no more than 1 minute if we have separate lines in front of each cashier. For the case of a single line in front of a pool of cashiers, we can use the chart in order to figure out the minimum number of cashiers needed in order to ensure that customer waiting times are 1 minute or less if we have a single pool of cashiers with a single line in front of them.